Hello everyone, this is Tim Meyer, and I'm here to present to my organization the Week 8 assignment from my class that describes the Jishuhosen pillar at Whitmore and all the things that we have done to make Whitmore really be a part of this pillar. So Whitmore, as a general overview, we manufacture specialty oils and grease. We have the capacity to produce over 20 million pounds of oil and grease per year as sellable product. We have a large amount of utilities. Utilities can range anywhere from a nitrogen generation system to steam boilers. We have 2 air compressors. We have 3 thermal fluid systems. We have a chilled water system. And we also have a air scrubber unit, all of which require periodic maintenance. Manufacturing is almost 100% automated. We have a number of automated valves and computer systems that are running within our facility that all help with getting the products made in an orderly fashion. However, a lot of it does require some maintenance. So the Jishuhosen pillar was also known as autonomous maintenance. So in this pillar, there are certain key factors that are associated with total productive maintenance. And basically, it takes everyone from within the facility to really contribute to making maintenance more effective. So as part of the pillar, we really encourage operator interaction with basic maintenance. This is very important for us because we can really free up a lot of the maintenance and engineering time so that they can focus on more value-added business as opposed to taking care of basic maintenance tasks that can be performed by operation personnel. Our operators here at Whitmore, we perform a multitude of tasks that would fall under this autonomous maintenance, one of which is cleaning. Housekeeping is very important to us. As a grease manufacturer, we have a tendency to create quite a mess. If we don't keep up with it, it can get out of hand. Inspections are another part of the operator's task. So your basic inspections, which would include anything from visual, hearing anything different, smelling anything different, that would all be a part of the tasks. Also lubrication. So simple lubrication that would easily take a look at the oil level in a gearbox and adjusting the level of the oil inside by adding or taking some out depending on what's required. These are all very basic tasks. Also, there's troubleshooting that needs to go on. From an operator standpoint, troubleshooting really takes care of the small stuff. If a valve is failing to open from the automation system, a quick look at what could be the cause is something that an operator is tasked to do. So really the driver that's been behind implementing this autonomous maintenance has been our recent product expansion. So our expansion has almost doubled our size in the past few years, but we haven't added any maintenance personnel to help with the acquired equipment, the new utilities that are in place, and things like that. Also, the other driver towards it is automation. With automation, you have more computer systems, more devices, valves, temperature probes, pressure transmitters, just a whole bunch of new and individual devices that really need a daily look at from an operator standpoint. The challenges to implementing this autonomous maintenance pillar was really the lack of knowledge of automation systems and devices. This being a brand new system for all of us, there's always going to be some issues. And trying to work out the kinks and diagnosing problems are all part of it. But really the lack of knowledge has really taken us back, and we really try to get ahead of it. And I think now that it's been implemented for a couple of years, we've certainly had a greater deal of operator interaction and troubleshooting to help us figure out where the issues are. Another challenge was a significant amount of resources for training. Um, you know, a lot of these basic maintenance tasks may not be so inherent as they are to someone else. So a maintenance tech may be more familiar with checking gaskets and looking at oil levels and just knowing how things operate. Whereas operators, they really may not have that background. Their background is more in manufacturing, so they know how to manufacture a batch. They know when to heat it up, when to cool it down, and things like that. But really, the benefits we've experienced out of this implementation has been maintenance and housekeeping improvement. Maintenance has really gotten the ability to focus on the areas that they need to focus on, particularly keeping up with PMs and work orders, ensuring that the large equipment that has a potential to have a delay on the entire facility is being kept up. And really, the housekeeping has been improved. Again, manufacturing grease is a dirty business, so keeping up with housekeeping has been very important. And I think your quality improves as well as your overall character within the facility. Everyone wants to come to work in a nice, clean facility. No one wants to come into something that's dirty and not desirable to be around. And maintenance is really moving closer to predictive maintenance. Now that operators are dealing with the equipment they're used to dealing with every day, if something sounds different or if it looks different or smells not the same, smells like something's burning, the vibration that you're used to feeling while you're around the mixers, if those aren't there or have changed frequency somewhat, it's a good indication that something may be about to fail. So getting into a little more detail as to what the operator tasks are. First one, cleaning. Again, we kind of touched on housekeeping, but it's difficult to clean if for every shift we do not address the issues that are up. If you look at the picture down at the bottom left during mid-shift, that's about what the top of a mixer would look like after someone was finished adding powders to the mixer. If you look to the right, at the end of every shift, that's the standard that everyone should be operating with. So at the end of every shift, I expect mixers to look this way. If we don't, it can really get out of hand. The finished material that we have in the facility is really tacky and dark, as grease is meant to be. Grease is meant to stick to metal and to help lubricate, but be tacky all at the same time. So our product does well at what it's supposed to do, it just makes it very difficult for cleaning purposes. Our raw materials don't help out either. Graphite, molybdenum disulfide, and carbon black are three of the usual suspects that would cause us a lot of problems. They are very fine powders. They're typically handled in 50-pound bags, and they have the tendency to fly away and cover all of our equipment in something of a fine dust. So inspection. The second part of operators' tasks under this pillar were visual inspections. So, as they're working on a series of 4 to 5 mixers in their area, the gearbox lubricating level for each one of the agitators is a good thing to check before every shift. If one of those were to fail, we would have the mixer down for quite some time. And if it were to really crack one of the gears because the lubricating oil level wasn't checked and hasn't been replenished, then we could have some real issues and very costly expenditures to replace. The gasket present and seated. So one of our vessels is a pressure vessel, and if this pressure vessel isn't checked for a gasket, you'll know when the pressure rises in the mixer because you will hear it whistle. So gaskets present and seated is another very good visual inspection. The vessel mechanical integrity. This is the absence of cracks and deformities within the equipment that you operate. It's pretty obvious if you see a crack in a vessel, something is not right with it. Lubrication. I thought this was a very interesting part. The study guide that we looked at had actually the parts that we own and sell ourselves. So we manufacture our own lubricants that would get stored in a system such as this. It's a color-coded system. We'll call it idiot-proof, but you don't have to remember anymore or what ISO grade viscosity oil goes inside a gearbox. All you have to do is match up the yellow tag with the yellow drum, go to the yellow spout, and dispense the oil you need into the jug. And you go over, you take it in. It's a very clean, very efficient system. And this system is, this particular one is designed by OilSafe, which is a subsidiary of Whitmore. So basic troubleshooting, we look for seal leaks, bolts are tightened, gaskets seated, clearing valve actuators of debris in case any of that fine dust gets up in the valve actuators. We don't want to make those stick. And cleaning work areas are also parts of minor repairs and basic troubleshooting. The production data, operators do not need to record any information besides what's on their batch tickets and into our ERP system. Instead, they use the batch historian. The batch historian uses temperature profiles, pressure profiles, cycle times, run data, amp draw, and torque. All that can be tracked and trended throughout any time frame in our facility. So in conclusion, the principles of the autonomous maintenance pillar is important to Whitmore in the maintenance strategy. We've seen a lot of benefits. A change in culture has certainly been taking place and was a difficult thing to get past, but I think we have gone and are reaping the benefits of that now. There's been a significant amount of training, which is good for everyone in their personal and professional lives. And the failures that we've seen are not due to the lack of minor repairs. It is large, equipment or something that is beyond the minor repairs. Also, our overall housekeeping has been improved. So I want to thank you for your time. These are some references that we use to build this presentation and have some of the ideas and concepts of this autonomous pillar. Thank you very much.